Good morning, students. Today we will study Newton's laws of motion. This chapter is very important for class 11th students. Here we learn about the force, impulse, momentum and the different form of force as well as friction. So first we will start from force. What is the force? What is the concept of force? As you know, when a force is a push or pull, when a body is pushed by some constant force, then it is moved a certain distance, or pull by some means like a string, then it moves in particular distance. So as you know, a force is a push or pull. It is a vector quantity, that is, it has both magnitude and direction. Vector can be represented in three-dimension vectors. As you already know about the vectors in 2D and vectors in 3D. So F vector is equal to Fx I cap plus Fy j cap plus Fz k cap. This is the force is applied by any body in three different directions, where Fx and Fy and Fz are the x, y, z component of force. It has some dimension. So first we will discuss about the system. What is the system? A system consists of objects whose motion is to be analyzed. In this chapter, we will be analyzing the motion of rigid bodies. What is the forces and their classification? Force, it is distributed into different form. First is system-wise. System-wise means external or internal. You can say when the force is applied by the surrounding on the system, and by the system on the surrounding, or by the system on the system, or by the surrounding on the surrounding. I hope the concept is clear. So we will discuss first is system-wise. In system-wise, force is again in two types. That is, one is external force and that is internal force. And next one is source. This is field force. This will be study after work, energy, power and rotational motion. This is in gravitational. As you know, gravitational force is a field force. Electrostatic force is a field force. Next one is reference frame. In reference frame, we will discuss about the real and the virtual conditions. Virtual is similar to pseudo also. And next one is nature, by nature forces. Nature forces, this is again in two types, that is conservative and non-conservative. Conservative forces, these are totally independent on the path, and non-conservative, depends on the path followed by the object. So here the first classification is self-explanatory. All forces in case of dynamics of a particle can be classified into two ways with respect to its origin, as contact force and non-contact force. This is very important for students. We can characterize the forces into two different methodology. First is contact. What is the contact force? When the body is in actual contact, like normal force, tension force, friction force, these are the contact forces. And when the body is not in actual contact, I will read here. Contact force, forces experienced by objects in physical contact are contact forces. The component of the contact force normal to the surface of contact or line of contact is usually known as the normal reaction. A component of the force parallel to the surface of contact is known as friction force. Next one is non-contact force. In non-contact force, Bodies can exert forces on each other without actual physical contact. This is known as action at a distance. Such forces are known as non-contact forces. For example, gravitational Coulomb repulsion between like charges. See, a gravitational force, in this forces, body is not in actual contact. Electrostatic forces, charged bodies are not in actual contact. So these are the example of non-contact force. For the moment, we will deal with actual forces. Suffice it to say that there exist pseudo forces acting in a non-inertial frame of reference. Pseudo force is also known as false force, imaginary force, which will we discuss later. Next, nature forces may be conservative or non-conservative depending on whether work done against them by an external agent is recoverable or otherwise. This will be discussed in the work energy power chapter. Next force is important. This is tension. You can see the diagram. In this, a body is pulled by a force. This is exactly, you can say this is the tension force. When a string, thread or wire is held taut, the ends of the string or thread or wire pull on whatever bodies are attached to them in the direction of the string. This force is known as tension. One important thing, string having mass also and string having without mass also. Generally, when we discuss about the tension, then the mass of the string is negligible, inextensible string. But if the string is massless, then the tension T is same magnitude at all points throughout the string. But if it has mass, then the tension is different at different points. We will discuss this concept in free body diagrams. See, one of the example is given. This is very important example. You can see here. The direction of tension is always away from the point. You can see when you pull your friends, then you applied a force on your friend, and the same as your friend also applied the force on you also. So the direction of tension is always away from the point of attachment to the body. In the given figure, two segments of tension act at O outwards. You can see the pulley, and in pulley the point is O. The same kind of tension is there because a string is having no mass. Segment of tension act at O towards A and B. For the wedge, there are two segments of thread at the point of attachment O of the body. Hence, two tension act on the wedge, one along OB and another along OA. Hence, the tension act away from the point of attachment along BO. I hope the concept is clear. Next force is spring force. What is the spring force? This is also a very important kind of force. In spring force, generally when you pull the spring and release it, then it oscillates about its mean position. The mean position we will discuss in the chapter oscillation. Whenever a spring is compressed or extended, the elastic force developed in the spring, which helps the spring to restore its original position, is known as spring force. Force in extended, we also discuss later on the concept of restoring force. In spring force, force is in an extended or compressed spring is proportional to the magnitude of extension or compression. As you know, F is proportional to X. The magnitude of the force is directly proportional to the displacement, but opposite in direction. This is also called restoring force. So, spring force is F is equal to minus of Kx, where K is positive constant, also known as the spring constant of the spring. And this K is inversely proportional to the length or compression or extension. Where X is the compression or elongation from the natural length, Next type of force is normal reaction. This is also very important force. Normal reaction, when the body is in actual contact. Suppose a block is kept on the table. So block is applied a force on the table, same as table also applied the force on the block. So what is the reaction given by the table? This is called normal reaction. The normal reaction is always, it is also follow the Newton's third law of motion. And when an object is kept in contact, either it is a point also, not, you can't say this is hold the body, even if a point, this also apply a reaction on the object. Suppose if you kept your hand on the wall, so you apply the force on the wall also react in opposite direction. And one important thing, this is very important thing is here, normal force is always perpendicular to the surface in contact. But again, a very good example, when the body is glued to the surface, then the normal reaction is generally in inward sense. But when the body is kept on the table, then it is in outward sense. The normal reaction is always perpendicular in direction. It is a type of contact force. The work done by the normal reaction is always zero. So this force is very important in the terms of free body diagram. We can see the different diagrams in case of normal reaction. I hope the concept of normal reaction, tension and the different type of forces is clear. Next, we will study about the Newton's laws of motion. What is the Newton's laws of motion? First, I will give the concept of inertia. What is the inertia? Inertia means, you can see, when an object is kept on the table, it has tendency to remain at the table. If a cycle is moving with velocity v, constant velocity v, then it has tendency to move with same velocity. If you resist, then it opposes the motion. So here the inertia, it is the inherent property of a body which always opposes the change in state of rest or motion. Inertia is generally defined by the mass of the body. Whatever the mass, inertia is directly proportional to mass of the body. So inertia is directly proportional to mass of the body. If the mass of the body is 10 kg and if the mass of the body is 100 kg, then more mass means more moment of inertia. I hope clear. So according to Newton's first law of motion, I will read, every body continues in its state of rest or of uniform motion in a straight line unless vector sum of all external forces acting on it is non-zero. The tendency of material bodies to maintain their velocity constant is known as inertia. Mass is a measure of inertia, as already discussed. When an external force on the body, it changes its velocity. It means this opposes the change in motion. This is very good. Inertia is again two types. It is of two types. One is inertia at rest or inertia of motion. You can take one example of when a passenger is moving in a bus and when the driver applied the brakes, then the two types of inertia is seen there. Inertia at rest, lower part remain at rest, but upper part is moving. So this is called inertia. Inertia is an inherent property of a body by virtue of which it cannot change its state. That is, rest or motion by itself. Again Newton's second law of motion, but before we will discuss about the momentum. What is the linear momentum? Linear momentum of a body is defined as the product of mass and velocity. Suppose a truck is moving with 60 km per hour and a car is moving with 60 km per hour. Which one has greater linear momentum? Then you can realize the truck is moving with same velocity, but it has more linear momentum. So you avoid the path of the truck. So the momentum is defined as the product of mass and the velocity. When we discuss the Newton's second law of motion, then momentum plays an important role. You can see the rate of change of momentum, linear momentum of a body, is directly proportional to the applied force and occurs in a direction of the force. But one thing is mentioned here, the force should be external, or if this is happened by the internal forces, then the force should be mentioned in internal also. The force, external or internal forces should be mentioned. Whatever kind of forces be applied. The Newton's second law is the rate of change of momentum of a body is directly proportional to the applied force and it occurs in the direction of the force. Suppose if you apply a body, if you apply force on the body, then body is moved in the direction of the force. If it is applied in some angle, then it moves in the horizontal component of the force, in the direction of. So dV by dt is proportional to F. Momentum is the quantity of motion possessed by moving body. As we have already discussed the example of truck and car. Momentum, it is a vector quantity and for a small enough velocity v less than c. This is very important. In Newton's laws of motion, we will discuss about only the concept of Newtonian mechanics. Because in Newtonian mechanics, we will discuss v is less than c. In your daily life, you can see a truck is moving with 60 km per hour. You can't say the truck is moving with 3000 meter per second. So the Newtonian mechanics is applicable only when the v is very less than c. It is given by. Otherwise, it will fail. P is equal to mv. Put the value of mv and differentiate this one. The d by dt of mv proportional to f. M dv by dt. dv by dt, this is the rate of change of velocity, instantaneous rate of change of velocity. Instantaneous means the velocity of the particle or acceleration of the particle at any moment. So dv by dt, m dv by dt is proportional to f and the proportionality constant is k here. F is equal to k m dv by dt. But you know, instantaneous acceleration is given by a is equal to dv by dt. Therefore, F is equal to ma. This is the Newton's second law of motion. And we will discuss more application of second law of motion after the study of Newton's third law of motion. Next one is Newton's third law of motion. This is very important concept. Newton's third law of motion, generally you can see when an object is kept on the table, then the force is applied by the object on the table and the table is applied force on the object. It means this is the action and reaction. You can see the action and reaction. So suppose you pull an object doesn't move, then again action and reaction there. So to every action there is an equal and opposite reaction. This means that if a body A applies a force on the body B, then the body B will also exert force on the body. But one important thing is there. The force on A due to B is equal to minus of force on B due to A. force on A due to B is equal to minus of force B on A. Force, but the magnitude is same, but the direction is different. You can simply you can simply see in your daily life example. Suppose you are sitting in a table, then you apply a force on the table, and the table is also applying a force. So you can see the magnitude is same, otherwise table will broke. Magnitude will same, but direction is opposite. This is the Newton's third law of motion. Next important topic is impulse and linear momentum. What is the impulse and what is the linear momentum? Linear momentum, as we have already discussed, what is the relation between impulse? Impulse, what is the impulse? Impulse, when a force is acting on a body for a very short interval of time. Suppose a ball is coming on the bat. This is for very instant, not for very longer time. This is for very instant. The batsman hit the ball for a instant time. So the force on a body for a very short interval of time, this is called impulse. And impulse and momentum have same relation. The formula of impulse is di is f dt, and I is equal to, this is integration t1 t2 f dt. This is the impulse. If you integrate this one, then you can find impulse is equal to change in momentum. Impulse momentum theorem, it is also called impulse momentum theorem. Impulse, whatever the impulse is applied on the body, this is equal to change in linear momentum of the body. We will discuss more example about this in the next one. This is the, therefore you can see the derivation I is equal to P2 minus P1. ठीक है?